Welcome! In today's lesson, we're going to learn how to find derivatives of inverse trig functions. This is section 4.5 in your calculus text. The 6 formulas for the inverse trig functions can be found on page 151 of your text. Right now, these aren't something that you're going to memorize. So I suggest going to your textbook and printing off this page for this assignment, or at the minimum, making sure that you have it open in a separate window. For the most part, this section asks you to apply a lot of the concepts we've already used. So you're going to be using the chain rule and the power rule. Other than that, using these formulas is kind of more algebra than new calculus concepts. So what we're going to do is we're just going to work through a couple problems of evens from your textbook. So these are pretty similar to, or of odd problems, excuse me. So these are pretty similar to the evens that you'll actually be assigned. So again, for working through these, you may want to have your book open to page 151 so you can refer to these. The first problem asks us to find the derivative of the inverse sine of 4x. Take a moment to refer to your table and find the formula for the inverse sine. The basic form says that the derivative of inverse sine of x is 1 over the square root of 1 minus x squared. Okay, our problem looks pretty similar to this. However, instead of having an x, we have a 4x. So that tells us a couple things. First, wherever there was an x in a formula, we're going to put 4x. Second, because we have an inside, we need to use the chain rule. We're going to have to multiply by the derivative of 4x. So let's start with the first part. Just replacing x with 4x. Okay, so the first thing to notice is that the whole quantity 4x is squared. 4x quantity squared means I'm squaring the 4 and the x. So in other words, this would actually be 16x squared. Make sure you don't make that error. And then we're going to multiply this by the derivative of the inside. Okay, our inside is 4x. The derivative of 4x is 4. I'm just going to square that 4x. So I'm going to write that as 1 minus 16x squared times 4. I could put that 4 on the top. So my answer would be 4 over the square root of 1 minus 16x squared. A lot of people have a desire to simplify this down and try to figure out more algebra. In general, it leads to algebra errors. I suggest you leave this as your answer. On the AP test, if you try to simplify something down and make an algebra error, you are going to lose points. So unless it asks you to, or if it's a multiple choice and it's a simplified answer, it's okay to leave your answers like this. Let's look at a second one. Find the derivative of y equals the inverse of secant x quantity squared. Okay, so this one, again, is going to be a little bit different because we have to use some of our old principles. We have to use the chain rule. First, let's start with dealing with that squared on the outside. Remember, when we talked about the chain rule, we have to deal with the outside first. So the chain rule says take the derivative of the outside and leave the inside the same. So we would start by finding the derivative of the outside. To find the derivative of the outside, we take that power, multiply it down to the front, leave our inside the same, and then we're going to lower the exponent by 1. Okay, lowering the exponent by 1, 2 would just become 1. Then we're going to times that by the derivative of the inside. So here's where we use the new stuff. Again, refer back to the table on page 151 and find the derivative of inverse secant. From your text, you can see that the derivative of inverse secant is 1 over the absolute value of x times the square root of x squared minus 1. Again, we're just going to leave our answer as that. No simplification necessary. As you can see, this problem required us to use the chain rule, so old information, and then it was kind of more algebra. We just plugged in the formula. It's a lot less complex than it might look. For our last example, we're going to find the derivative of inverse tan of natural log of x. In your book, we can find the formula for inverse tan. The derivative of inverse tan is 1 over 1 plus x squared. Again, we don't just have an x, so we're going to have to deal with that inside as we did in that example 1. So our derivative, we're going to have 1 over 1 plus, okay, we don't have just x. Where we have our inside is natural log. So 1 plus the natural log of x squared times, here we have to use the chain rule. We have to multiply by the derivative of the inside. So if we look at natural log of x, remember that the derivative of natural log of x is 1 over x. So we're going to use the chain rule and multiply by the derivative of natural log, which is 1 over x. Again, it would be okay to leave it as this. If you want to simplify it, that's okay. 1 over x times the quantity 1 plus natural log of x squared. Again, pay attention to your algebra. If you correctly use the chain rule and watch your algebra, you're probably going to do quite well on this section.